Since we've gotten pretty good at calculating our one substance stoichiometry problems, which are problems where we only had one given amount, we need to start looking at limiting reactant problems. Now, a limiting reactant stoichiometry problem, and I wrote some information up here on the board, a limiting reactant stoichiometry problem is characterized by having the amounts of two or more reactants. And what happens in these reactants is, in our sample problem, we have 15 grams of HCl and 15 grams of calcium hydroxide. When we do the reaction with these, one of them will run out first, which will limit the reaction and stop it. The other will be found to be in excess. And so what we need to do is figure out how to do these problems. And I'll tell you now that the correct answer is, when we do the problems, it's the one that will give us the smallest amount of product formed. And so what we can do is just to simply follow the exact same steps that we did before, but this time we'll just do the problem twice. So we'll do the problem once using hydrochloric acid's mass, and then we'll do it again using calcium hydroxide's mass, and figure out which one gives us the smallest amount of either product. In this case, I'm asking you to tell me how much water is produced, so we'll use water as what we're solving for. So we're going to follow the exact same steps. So the first thing we have to do is balance the equation. And so we need a 2 in front of the HOH and a 2 in front of the HCl. Then we need to convert our given amount to moles, use the coefficient ratio, and convert back to any unit. Now I'm going to do this as a single big problem for HCl and for calcium hydroxide, just to save some space on the board. And I'll tell you as I'm doing each step. So we've already done step 1. Step 2, we need to convert our given amount to moles. So we have 15 grams of HCl and 1 mole of HCl is 36.4. I've got it written down here on my paper, 36.458. So this much is step 2 in our stoichiometry problem. We convert to moles. Then we're going to use our coefficient ratio, and this is moles of HCl here. So I have 2 moles of HCl and 2 moles of HOH. And then, so this is step 3. And then 1 mole of HOH is 18.016 grams. And so when we put this into the calculator, we'd say 15 divided by 36.548 times 2 divided by 2 times 18.01, and we get 14.8 grams. If we use our HCl. Now we need to do the exact same type problem using calcium hydroxide. So I've got my 15 grams of CaOH2 and 1 mole of calcium hydroxide is, let me look on my paper, 74.096. So that's step 2 from up here. Exact same thing, it's over on that side of the board. And then our coefficient ratio of 1 mole of calcium hydroxide to 2 moles of HOH. Step 3. And then the final step, we're going to multiply by the molar mass of water. And that was 7.28. So 7.28 is smaller than 14.08. So calcium hydroxide is my limiting reactant. It gives me my smaller answer. So this is 7.28. And then I would put an LR for limiting reactant by the calcium hydroxide, so I know what my limiting reactant is. Then if I wanted to find the calcium chloride amount, I would use my limiting reactant now to find everything, because this is what's going to run out first. This is what determines everything about this reaction.